All right, I am here in the lab, and we are going to do the energy of dissociation. We are going to look at 3 different compounds and what happens when they dissolve in water. So, I've posted on Classroom the pre-lab questions for you to answer. I've posted the data table. You should be filling that out as you watch this. And I've posted the analysis, the post-lab questions. You should be answering those after we're done. So let's go ahead and get started. So here I've got my materials. I've got my balance here. I also have the 3 chemicals that I'm going to be dissolving in water here. I have sodium chloride, I have calcium chloride, and I have ammonium chloride. And we are going to, like I said, look at those and see how the temperature changes as they dissolve in water. So first of all, I need to get my safety equipment on. So let me go ahead and do that. All right, there we go. So go ahead and put my gloves on. Always have to wear gloves. Now the stuff that we're using, sodium chloride, that's just table salt, so that's not going to be too bad. Calcium chloride and ammonium chloride can be skin irritants, so I want to make sure that I have my gloves on. Not that it's going to kill me or anything, but it will irritate my skin, and I don't want to do that. So, and then goggles. All right, so I've got my gloves on. I've got my goggles. All right, let's go ahead and get started. So the first thing that we're going to do, part 1, we are going to dissolve the calcium chloride into 25 milliliters of water. So I'm going to get 10 grams of calcium chloride. So here's my calcium chloride, and I'm going to get 10 grams on my balance. So the first thing I want to do, turn it on, put on my weigh boat, make sure I hit tare so that I take into account the mass of my weigh boat. And then I'm going to measure out 10 grams of calcium chloride. So that's 1, 3.5, 5, 6. That's a big piece. So calcium chloride, I'll show you in a minute, but it's just this white powder. It's kind of chunky a little bit. All right, exactly 10 grams, perfect. So I've got my 10 grams of calcium chloride. Let me go ahead and show you what that looks like. So you can kind of see, right, it's this powder, kind of chunky a little bit, but I've got exactly 10 grams there. All right, so now that I have my solid weight out, I'm going to measure out 25 milliliters of distilled water. I'm going to use my graduated cylinder right here. And I'm going to measure out 25 milliliters of distilled water. And then I'm going to mix in my calcium chloride into my distilled water. So remembering when we use a graduated cylinder, we always want to measure at the bottom of the meniscus. So I'm getting close here. There we go. So 25 milliliters of distilled water. I'm going to put that into my beaker. Now, again, the point of this is we want to see what is going to be the temperature change as it dissolves in the water. So I'm going to take my thermometer, let that sit in here for a minute or two, until I can get my initial temperature. After I have my initial temperature, then I will add in that calcium chloride, which is right here. I'm going to take the calcium chloride, I'm going to put it into my water here and see how the temperature changes. And then you can record that on your data table, which, like I said, is posted on Classroom. Okay, so my initial temperature of my water is 19.0 degrees Celsius. So 19.0 degrees Celsius is my initial temperature of my water, 19.0 degrees Celsius. Now I'm going to take my calcium chloride, my 10 grams of calcium chloride, and I'm going to mix that in here. And we're going to see what happens to my temperature. So right now the temperature is going up. I don't know if you can see that, but we're already at 31 degrees, 31.4, 31.7, 33. So we are jumping up. I'm going to mix this up a little bit. All right, so my temperature is, okay, we're still going up. I'm going to watch this. I'm going to wait until I see the highest temperature. We're up to 42. Now, if I were to touch this, yep, that is warm. That is quite warm. We're going to let that sit for a minute. And I'm going to be watching the thermometer to see how high it gets. I'm at 42.7, 42.8. All right, and it's starting to go back down. All right, so 42.8 is going to be our final temperature for this one. 42.8 is going to be the final temperature for our calcium chloride. Okay? And its temperature is starting to go back down. So if I were to touch this, yep, that is quite warm. That's about a little bit hotter than body temperature. So 42.8. All right. Now I'm going to rinse off my thermometer so we can do this again. All right. So now I'm going to do the exact same thing, but this time I'm going to use sodium chloride instead of calcium chloride. So here I have my sodium chloride. I'm going to put that on my balance, on my scale. Make sure to tare. And I'm going to measure out 10 grams of sodium chloride. So that's about 2. All right, we're up to 8. A little more. All right, now to effectively see the difference between these different compounds that we're going to dissolve in water, I want to get as close to the same mass as possible, right? I want to try to eliminate as many variables as I can. So if I can get the same mass and mix them together, that will eliminate one variable, right? The amount should be the same. The mass of my stuff should be the same as I mix it together. So now that I've got my 10 grams of sodium chloride, now sodium chloride is just table salt, so you know what that looks like, but I'll show you anyway. There you go. There's some sodium chloride and 10 grams of it, 10.02 grams of sodium chloride. Now I'm going to measure out another 25 milliliters of distilled water so that I can mix these together. So again, remember, measuring from the bottom of the meniscus, I need 25 milliliters of water. All right, almost there. We're at 20. And up to 25. Okay, good. Just like the reason that I want to keep the mass of my materials the same, I want to keep the volume of water that I'm using also consistent. Again, to try to eliminate as many variables as possible so that the only difference between these different parts is what it is that I'm mixing. The masses are the same, the amount of water is the same, everything is the same. So I've got my thermometer. We want to start with my initial temperature. Should be very similar. Yep, we're at 19.1 degrees Celsius. So initial temperature for sodium chloride is 19.1 degrees Celsius. Now I'm going to take my sodium chloride and I'm going to mix that in here, make a sodium chloride solution, and we will look at the temperature. So my temperature is at 18.7. Mix this up a little bit. All right, so we're going down. We're at 18.2. As I keep mixing, we're at 18.0, 17.9. 17.9. All right, so the lowest temperature that we could reach with our sodium chloride is 17.9 degrees. So we went from 19.0 to 17.9. So it did go down 1 degree, but that's the lowest temperature that I'm able to read here is 17.9. All right, so there's our sodium chloride. That's part 2. Let's move on to part 3. Let me rinse off my thermometer first. Okay, we're rinsing off our thermometer. All right, now for the last part, we're going to use ammonium chloride. So that's this one here. This is ammonium chloride. Okay, and as you probably guessed, we're going to use 10 grams of it. Okay, now why are we wanting to use 10 grams? Well, same as we said before, try to eliminate as many variables as we can by using the same amount of all these different substances. So I'm going to try to get 10 grams of this. All right, so we're at 5, 9.5, oops. Oh, so close. Okay, so I'm at 9.97, so I'm 3/100ths of a gram away. I think that's pretty good. I think that's good enough. So let me give you an idea of what it looks like. Similar to the sodium chloride, this is ammonium chloride, so it's kind of a little crystal. But as you can see, it's starting to clump up a little bit, but that's okay. So I'm at 9.97 grams of ammonium chloride. And now, just as before, I'm going to use the same volume of water, 25 milliliters. So I'm going to mix in, so I'm going to measure out 25 milliliters of distilled water. Now, the reason we use distilled water instead of tap water is because distilled water doesn't have anything dissolved in it. Tap water has minerals and ions and other things dissolved in the water, and that can contaminate our results. So I'm going to use distilled water so that it's just water. It's pure water, nothing else in there. Again, try to eliminate as many variables as we can, trying to keep things consistent so that we're only looking at the difference between the substances that we're trying to measure. All right, so there's 25 milliliters of water. I'm going to put that into my beaker here. Okay, now I'm going to take my initial temperature of my water, which should be similar to what we just did. So I'm at 19.3 degrees Celsius for the temperature of my water, 19.3 degrees. 19.3 degrees Celsius. And now I'm going to take my ammonium chloride, which is here, and I'm going to mix that into my beaker, and we'll see what temperature change we get here. All right, we are down to, this is dropping pretty quick. I'm at 8.8, 8.9. Let me mix this up a little bit. Oh, this is cold. This is very cold. I'm at 7, 6.9, 6.6. See if I can get lower than 6.6. Oh, this is extremely cold. 5.8, 5.1, 5.0. 5.0. Oh, there we go, 4.9. Oh, and we're going back up. All right, so let's see if I can get lower than 4.9. Mix this up. 4.9, 4.8. All right, 4.8, 4.7. There we go. All right, so 4.7. Now, as I'm touching this, this is very cold. This is very, very cold. 4.7, so 4.7 degrees. So our final temperature for our ammonium chloride is 4.7 degrees. All right, so that's the lab. You have all of the data that you need. Yeah, so we have all of the data that we need. We have our initial temperatures for the calcium chloride, the sodium chloride, and the ammonium chloride. All of our initial temperatures were fairly close to each other. Then we have our final temperatures for the calcium chloride, the sodium chloride, and the ammonium chloride. That's what's going to be different, and that's what we want to look at. So you should have enough data that you can fill out your data table. You should have enough information that you can do that. And then you can answer the questions and turn in the lab. So make sure you do your pre-lab, make sure you fill out your data table, make sure you do your analysis and your post-lab. If you have any questions, feel free to ask, but thanks for coming out, guys. I appreciate it, and I will see you later. Bye.